Hello everyone, my name is Kunal Rathod and in today's video we are going to learn about C-loop disk scheduling algorithm. So without any further delay, let's get started. So this is the index slide which gives an overview about today's learning. Firstly, we will see what is disk scheduling algorithm. Then we will see why is disk scheduling algorithm is needed, important terms related to disk scheduling, types of disk scheduling algorithm, loop disk scheduling algorithm, C-loop disk scheduling algorithm, advantages of C-loop disk scheduling algorithm, disadvantages, and at the end we will see the conclusion. So before moving ahead, first we have to see what is a disk scheduling algorithm. A disk scheduling algorithm is an algorithm that keep and manage input and output requests arriving for the disk in a system. In a simple word, we can say that it helps us to manage the request, more specifically the input-output request. Basically, our disk is divided into several tracks, and these tracks are further divided into sectors. We can understand the disk scheduling algorithm with the help of an example. For example, let's take an example of grocery shop. Then the manager of the grocery shop is said to be the disk scheduling algorithm because it manages all the incoming and outgoing requests for goods of that store. Now, why is this scheduling is needed? Why? Because there are certain reasons. The first is multiple input-output requests may arrive by different processes, and only one input-output request can be served at a time by disk controller. बेसिकली हमारे डिस्क कंट्रोलर जो होता है वो एक टाइम पे एक ही रिक्वेस्ट को सर्व कर सकता है और अधिकतर ऐसा ही होता है कि मल्टीपल रिक्वेस्ट आ जाती है हमारे पास डिफरेंट डिफरेंट प्रोसेसेस से, तो हमें ये मैनेज करना बहुत ही जरूरी हो जाता है कि किस प्रोसेस को सर्व किया जाए और किस प्रोसेस को वेटिंग क्यू में डाला जाए. As shown in the figure, the disks are look like these cylinders, and this is the read-write head. It moves forward and backward. With the help of this read-write head, the data is entered and read from the disk. And this disk rotates circularly with the help of this splinter. Two or more requests may be far from each other to other, so can result is greater arm movement. For example, let's consider currently the read write head is here and it have to move to here. So we have to schedule the disk for it. Hard drive are one of the slowest part of the computer system and thus needed to be accessed in an efficient manner. Now before moving forward, we have to learn some important term related to the disk scheduling. The first is the seek time. As we know that the data may be stored on various blocks of disk. To access this data according to the request, the disk arm moves and finds the required block. The time taken by the arm in doing this research is known as seek time. For example, the, the disk is currently at the 50th position. It have to go to the 70th position to read the data. The time taken by the disk arm to move from 50th to 70th position is called the seek time. The rotational latency. The required data block need to be moved at a particular position from where the read and write head can fetch the data. So the time taken in this movement is known as rotational latency. This time should be less as possible as. The algorithm that will less time to rotate will consider as the better algorithm. And the third one is the transfer time. When a request is made from the user side, it takes some time to fetch this data and provide them output. This time is known as the transfer time. We can understand these three terms with the help of this diagram. For example, a data is here and this one more data is inserted in this block. So the time taken by the head to move from this block to this block is called seek time. And if the read write head position is here and we have to go to this sector, The time taken by the read-write head to reach there is known as the rotational latency. And the overall time of the rotation plus the movement of head time is called transfer time. Let's move forward. The third time is the disk access time. It is the total time taken by all the above processes. Disk time is equal to the seek time plus rotational latency time plus transfer time. Disk response time. The disk response by the disk processes one request at a single time, so the other request wait in a queue to finish the ongoing process of request. The average of this wait time is called disk response time. Actually, disk response time is the addition of disk access time plus the waiting time by the request. The next term is the starvation. The starvation is defined as the situation in which a low priority job keeps waiting for a long time to be executed. The system keeps sending high priority job to the disk scheduler to execute first. It is clear from the diagram that disk access time is the sum of seek time, rotational latency, and transfer time, while the disk response time is the sum of the disk delay queuing plus the disk access time. Now, let's take a look on the types of the disk scheduling algorithm. These are the types of disk scheduling algorithm: FCFS, first come first serve, SSTF, shortest seek time first, scan, circular scan, look, and CLOOK. In this video, we are going to learn about the CLOOK algorithm. Now, before learning about the CLOOK algorithm, we have to know about the look algorithm, because CLOOK algorithm is a modification of look algorithm. In this algorithm, the disk can move to the last request present and service them. After reaching the last request, it reverses its direction and again come back to the starting point. It does not go to the end of the disk. In spite, it goes to the end of the request. Let's consider an example. A disk having a 200 tracks. The request sequence is given as shown in the figure and the head is currently at 50 position. So by applying the look disk algorithm, the the head moves from 50 to 82, then 100, and keep moving until the last position 190, and that it moved to the next shortest distance shortest distance request, and we can find the seek time by the interval by calculating the interval. But in the CLOOK disk scheduling algorithm, the CLOOK disk scheduling algorithm is a variation of look algorithm for disk scheduling. It operates by scanning the disk in one direction only and services all the requests along the way until the last request in that direction has been serviced. They immediately turn to the beginning. The main difference between the look and CLOOK is जब last request को हम service कर देते हैं, in look we move to the next request, but in CLOOK we move to the initial point and repeat the process. Here are the basic steps involved in the CLOOK algorithm. First, we determine the initial position of the disk head, and then we sort the pending disk requests in the order in which they will be serviced, and then scan the disk in the chosen direction and servicing requests as they are encountered. When the last request in the current direction has been serviced, immediately return to the beginning of the disk and repeat the process. Let's consider an example. This is the same example we have taken for the look algorithm. While in look algorithm, we move from 50 to 190 and then we move to the 24th number request. But in CLOOK algorithm, we move from 190 to the 16th request and then we move forward to the 24th. You can see that the seek time in the CLOOK algorithm is less as compared to the look algorithm. This is the major advantage of the CLOOK algorithm. Now let's see the advantages of CLOOK algorithm. It provides better performance than the look algorithm because it reduces the number of head movements required to be access data on the disk. I think it's clear. It is relatively simple to implement and does not require a large amount of memory or processing power. It can be efficient in terms of disk usage because it scans only the area of the disk where data is located. Now, let's see the disadvantages of C-look disk scheduling algorithm. It may not be optimal in solution where there are large number of data to be read and written in one direction. It could lead to a large number of requests being queued up in the opposite direction. If let's consider an example, there is a queue given and there are certain requested. If the current head position is there and it started serving providing the serves to the requested, then it move here, then here, then here. During this time, the request from the left side remain in the ready queue. Therefore, this CLOOK algorithm is not optimal. Let me erase this. Now, the second point is it may not be suitable for real-time system where fast response times are critical, and as it does not prioritize requests based on their urgency and importance. In real life, we have certain priorities to our requested and jobs, but in this algorithm, there is no priorities. It work on only the nearest job. It may lead to starvation of requests that are located far away from the current position of the diskette. Now, let's conclude the today's video. The disk scheduling algorithm is OS is used to manage input and output requests to the disk. Disk scheduling is important as multiple requests are coming to the disk simultaneously, and it is also known as request scheduling algorithm. An algorithm in which starvation is minimum is considered as the efficient algorithm. So that's all from my side. I hope you like my presentation. If you have any queries, please let me know. Thank you so much.